Hello guys, the Empinated here. Welcome to this new series in which we are going to create a procedural dungeon generator. In this part, we will set up the orthogonal rotation of the room and a child class for the connections, basically the hallway. We are going to reuse the blueprints from the Procedural Room Generator tutorial since it will work with the same fundamentals, except that it won't be just a room now, it will be an entire dungeon. That's why I decided to make a separate series. However, I will continue developing both series in parallel because although they serve different purposes, they are closely related. Too much yapping, let's get started. Okay guys, so the first thing we need to do is to rename our room spawner to room spawner for dungeon, because although they have the same logic, they will serve like different purposes, so they will differ in some parameters and some setup. So yeah, let's open it up. Okay, so the first thing we need to do here in the V generator is to uh, put a little bit of order here, and let's create another variable for our rotator. So get vector rotation, because we want to rotate the actor in an orthogonal angle, that is an angle that sums 90. Yeah, like 0, 90, 180, 270, etc. Because this configuration won't work with any other angle, just the orthogonal. So let's create that. Let's create a variable, a global variable called mesh rotator. Let's connect it. And now here, this function is a little bit messy, so we need to put a little bit of order. So in order to control the rotation of each room, we need to get a function called a rotate vector. And it consists in a node with two inputs, the vector and the rotator, and an output with the rotated vector. So we need to connect our resulting vector here on our previously created mesh rotator. Let's connect it in the here in the zoom node. Let's split the struct pins, and also here the rotate vector node can add unwanted decimal values, so rounding helps snapping the result to clean angles, keeping the dungeon layout neat and aligned. And now let's do the same step in other functions. Okay, the first one will be the function of our modular actor, or unique function called get vector offsets. Let's copy and paste that, but with a little modifications. Okay, let's connect to get obviously our rounded vector again. Let's connect here the current vector, and here let's get our actor rotation. Okay, let's compile. Okay, let's do this one last time in the wall spawner function. At the middle of this function, also let's call the final results of our relative location, this relative location. Let's connect everything again and compile. You don't need to do anything else here with the rotation. When you're here in the cell spawner, I was forgetting to connect also the mesh rotator in the spawn transform rotation to control, the rotation of the entire mesh. After we made all the stuff related to the rotated vectors, I want to rearrange this part of the switch case in order to leave all the parameters with a variable. Let's call it the wall offset. Here we split the main math operation in two parts to store in the first one the difference between the offset and the tile thickness. This value will later be used in either the x or the y component, depending of course in the direction. We are putting the wall offset here. Then we just connect the result of wall offset with the sum of tile thickness to obtain the relative location in Z. Now let's finally rearrange some of the variables of the switch case. So yeah, now it depends only in variables and not just in numbers. And you won't have to put any number manually. Now we need to create a child class from the room spawner. Let's call it the connection spawner because we want to use the same configuration as the room spawner, but different um, with different characteristics. For example, we want to avoid spawning a mesh at the front or the back of the hallway, since those areas will already be connected to the entrances of the previous and the next rooms. In the case of a connection or hallway, we only care about the length of the grid y-axis, since grid x and grid z will always remain constant at 1 unit. That's why we must change a bit the setup of the grid z value in the grid generator. Let's edit this. Okay. And as we saw before, because we are controlling the rotation of each connection, it won't be necessary to spawn any mesh in the front or the back of the actual connection, because the connections will be already in the room. We are not interested in spawn any entrances inside the connections. And let's save it. And now let's edit wall spawner a little bit. Okay, the first thing is that we need to edit the random entrance spawner. Let's turn the possible directions array into a global variable instead of a local one. So yeah, we can modify its length from outside this function. Okay. Let's delete. Let's make a global variable called the random direction array. Let's make some changes here in the first part of the wall spawner. First of all, we need to create a boolean input called is connection. Then hit in true a branch and boolean. Let's connect here. Let's get the direction index from the current vector offsets of each grid actor. If that direction is either 0 or 1, which means front or back, and its connection is true, we'll remove those indexes from the possible directions array. As a quick reminder, index 0 is for front, 1 is back, 2 is right, and 3 is left. This logic helps us avoid spawning meshes where the hallway will be connected. Otherwise, we'll add the current vector to the available size map. Okay, so let's compile, save, and we're almost there. Yeah, here I forgot to break these connections. So if the grid position don't contain the current array element, we need to pass this other new section, okay? Let's go to the event begin play in the event graph of the connection spawner. And let's change the input to true, because it is a connection, and obviously let's leave the is connection in the room spawner. Now let's create our actual function for our dungeon spawner. Let's call it BP Dungeon Generator. Let's delete these variables and let's create a unique function of this tutorial that is called, I don't know, dungeon spawner. Let's connect it to the event begin play. Let's make the same variables of tile thickness and offset as the room spawner and the connection have. Tile thickness, this a load, and this will be the offset. In my case, the offset is 200 and the tile thickness is 40. So we have to make the same calculations as before in the room spawner. The offset minus the tile thickness divided by 2 plus the tile thickness. This part will help us preventing any kind of overlapping. Let's promote to a local variable called location offset. Now let's spawn actor from class. Let's connect our room spawner for dungeon. Let's split stroke the pin. Let's connect here the actual location of the dungeon generator. Then we need to create a for each loop. And we need to obtain from the generated initial room the door indexes. Let's get the entrance indexes array, sorry, so we can start spawning each connection from those positions. Then we need to find in the map of wall position to get the current position of each door index in order to alter the rotation and the location of each connection or the hallway. Let's switch one end. Let's create the cases from 0 to 3. This means each direction, as you know. And let's create two variables. One called, I don't know, the room location. And the other one, room rotation. One is a vector and the other is a rotator. Let's fast forward to set the variables. With the room rotation, we're just interested in rotating along the z-axis. Like I said, this only works with orthogonal angles. So after we finish to set the cases, we need to spawn an actor from class again. In this case will be our connection spawner. Let's split this struct of transform. Let's put here the rotation and here a sum of the current array element, a vector, plus the room location. Let's compile and save, and let's test it. Let's add some dimensions for our initial room and their connections. Okay, so let's spawn, I don't know, an initial room of 2 by 3 by 2 with up to 4 entrance. Yeah, let's spawn 3. I don't know. Now in the connection spawner, let's set up a length of um 5 tiles. Remember, grid X and grid Z always stay constant. So with this setup, we only need to set grid Y, that means the length. Of course, feel free to adjust the code according to your necessities of your project. Okay, after we did the final steps, let's test this out. So yeah, it works. As you can see, the 3 hallways were spawned right next to each entrance, just like we planned. This makes sure all rooms connect properly. So yeah, we have finished for now. We got an early version of a dungeon generator that spawns the initial room with a connection at each of the entrances of the room. Keep in mind that you can spawn up to 4 entrances, one on each side. Thanks for watching. Remember to follow me on X at TheMPinated and leave a like or subscribe if you found this tutorial useful. Bye.